Good morning. This video is for those of you who are absent today, Monday, March 20th. The bell ringer, very quickly, I asked the kids to check to make sure that they handed in their chemical reaction, Chapter 1 scientific argument. I believe there are quite a few of you that have been absent, that were absent maybe Thursday and Friday before spring break. So you didn't get this assignment. This is something that you're going to have to make sure that you get finished when you get back. I'll explain it to you. We'll just have to set up a time to make sure that we can go over this stuff with you, okay? Go ahead and log into Chemical Reactions 2.1 and let's do the warm-up activity together. Let me do this slideshow. So if you remember, at the end of Chapter 1, we discovered that the substance, the reddish-brown substance, was not the same as because it didn't have the same chemical properties as the lead pipe or the fertilizer. And then we saw the atomic model of the reddish-brown substance, which we understood to be rust. And it was not atomically, like the atomic makeup, the atoms that make up the molecules were different than what made up the pipe substance and the fertilizer substance. So we were able to say that the reddish-brown substance was not the same as either the pipe or the fertilizer. So then Dr. Samarion gave us this email, and she says, nice work identifying the mysterious substance as rust. The people of Westfield are very grateful for your explanation. However, now they want to know where the rust came from and how it got in their water, which totally makes sense because if you're living in that neighborhood, you wouldn't want to have rust in your water. You'd want to know where it came from so that you could fix it. She says rust can form naturally over time when iron is exposed to water or air. So I looked at another neighborhood that uses a similar well system to see if they had rust in their water too. However, none of the neighbors reported a problem with rusty water, and I didn't find any fertilizer in the water sample I took from their well. Seems like something unusual is causing the rust to form in Westfield's pipe. So we're trying to figure out how the rust formed. And there's lots of different things that keep this neighborhood in Westfield that's different than what's going on in the neighborhoods around them. So something crazy is happening here. We need to figure it out. So in order to figure out or to keep investigating how the rust formed, we're going to consider the following three claims. Claim number 1 says the pipes changed into rust. So there is a transformation of the pipe into rust. Claim number 2 says the fertilizer changed into the rust. There was a transformation from the fertilizer to the rust. And claim number 3 says the pipes and the fertilizer changed into rust. So there was a transformation where the pipes and the fertilizer became rust. So we're waiting for these answers. I want you guys to go ahead and just click on which one seems most likely to you right now. And in class, we didn't really discuss them. I just had the kids decide which one they thought it was. And then we'll come back to this later on in the next couple of lessons. All right, so our new Chapter 2 question is, how did the rust form? And we're looking at these three claims. Now, in today's activity, we have this investigation question. We're trying to figure out, is it even possible for one substance to change into something completely new? One thing I want you to consider is if you have water, liquid water, and we increase kinetic energy, that's going to make the water evaporate and it'll turn into water vapor. And if we decrease kinetic energy, that's going to make the water freeze, right? So now it is an ice. It's ice cube. So it's still water. Is there ever a time when it's possible for a substance to change into a different substance? And that's our question. So I want you to think yes or no. Do you think a substance can change into a different substance? Can one thing, water, plastic, pipe, fertilizer, can that turn into or become something completely different? And in class, we had 2 activities that we did in order to gather evidence. The first one we did, I'm just going to describe to you because you weren't here, but we had 2 different substances. We had, on the left, you can see we had sodium carbonate, and then on the very right, we had calcium chloride. These were solid white powders. They look like this. There's calcium chloride and sodium carbonate. And then I dissolved them in water. And so you can see when they're not dissolved in water, they definitely have different properties. Even though they share some properties, they have different properties. And key concept number 1 says different substances have different properties. So after they were dissolved in water, they look exactly the same. I'll come get you. So the calcium chloride and the sodium carbonate, if they were not labeled, you wouldn't know that they were two different substances. They both look exactly the same. Now, because they're dissolved in water, they're both a liquid. They're both kind of semi-translucent. They are kind of a whitish gray in color, and there's really no differences, okay? Then I had the kids pour the two together. So they took sodium carbonate and they poured it with the calcium chloride in that middle cup called the product. And they weren't supposed to mix it or stir it because that would not allow that chemical reaction to occur. And what they found was it created this solid, and it was kind of slimy. It looked kind of grayish white, translucent slime, but it definitely was like a clump of this kind of slimy stuff in the middle of water. I had the kids dump out the water. We created this filter system using a cup and a paper towel, and I had them just kind of isolate that product, trying to get that water away from it. And what they found was as the water evaporated, the product turned into this white powder. And so it definitely was something completely different. Okay. The question then is, what happened? The substance changed into different substances. We saw that. Whereas it was a liquid before, it was a solid. And it also did not dissolve in water. Whereas the solid, we had, let me show you. We had these solids, calcium chloride and sodium carbonate, but they dissolved fully in the water. And this other thing did not dissolve in water. All right. So now we're thinking, let's come back to that original question. Do you think the substances change into new substances after they were mixed? And we talked about the evidence. And the evidence was, honestly, that they had different properties. And so that reminds us of key concept number 1 again. It says different substances have different properties. So was there any evidence that they were not able to observe that might make our argument stronger? And the answer is yeah. If we were able to figure out what was going on at the atomic scale, then that would really help us to understand what was happening. So I had the kids go to activity 3, screen number 2, and we recreated what we saw. And so I'm going to, I'm doing this as a spur of the moment, so I'm sorry, it's going to take me a second. But I'm going to log on to Amplify, and I'm going to show you this. And you certainly can go into yours and do it with me at the same time if you want, just so that you can see, or you can just watch this. But I'm going to show you what happens on the atomic scale model, or with an atomic scale model, so you can see what actually is happening to the atoms in the molecules during this reaction. So we're going to go here, and I'm going to open up my simulation. Okay, so I want to make sure that I'm in laboratory A mode. I am, so I'm just going to go ahead and close that. Like I said, we're going to recreate what we just did in the classroom. And the first thing I'm going to do is I'm going to grab my calcium chloride, and then I'm going to mix that with my sodium carbonate. Okay, so calcium chloride plus sodium carbonate. And let's go ahead and test it. Now I'm going to repeat this, kind of loop it over and over again so you can watch what happens. But when we first start out, you could see, and it happened real fast, and so I'm going to show it to you again. Let's go ahead and loop it, but I'm not going to play it yet. So if you're going to notice that I've got this molecule on the left, and that's the sodium carbonate, okay? It's Na2CO3, so there's 2 sodiums, those are the purple, 1 carbon, and 3 oxygen, Na2CO3. And then I have the calcium chloride, and that's 1 calcium and 2 chlorine atoms. Now, these are repeating molecular structures. Okay, they're both solids, and so before they were dissolved, and so they would be repeating over and over and over again. And I want you to notice what has to happen first before anything. Okay, look, they're both still together, but now, look, they broke apart. So the first thing you notice is that these molecules have to break apart, and then they rearrange to form new molecules. And now we see we've got two new molecules, this first one here, and then the NaCl. And I've got actually two molecules of that substance. So I'm going to play it again. I want you to watch it again. See, they break apart, and then they form new bonds to form new substances. The last thing I want you to do is I'm going to rewind this. Now look down at the bottom in that kind of gray semicircle. It says the testing, the lab conditions was, first of all, these had to be dissolved in water and it was at room temperature, which means if I poured those two solids together, there's no way that they would have had that same reaction. So the only way that this chemical reaction occurs is if both of those are dissolved in water. And the water has to be at room temperature. Okay, that's important, and I want you to really pay attention to the lab conditions in upcoming sims because it makes a difference whether or not a chemical reaction occurs. All right, so they break apart and break apart again, and then they bond together and they form new substances. If you come over here to the right, click on results. It's going to show me, these are called your reactants. So if I was in a math problem, and let's say I had the number 2 and I had the number 3, and I told you I wanted you to add those together, the math equation would be 2 plus 3 equals, right? Well, in a chemical reaction, the reactants are the beginning part of what you have in the beginning, what you have at the start. And so we would say sodium chloride plus, we would say calcium chloride plus sodium carbonate. And instead of saying equal, we would say yield. See that arrow? So instead of saying equals, we would say yields. Calcium chloride plus sodium carbonate yields sodium chloride and calcium carbonate. What we made is table salt and chalk. And remember that only occurs when the calcium chloride and the sodium carbonate is dissolved in water. Down below here, this is kind of cool. I can restart the whole thing, watch it happen right here. Or if I'm like, meh, I'm good, I just wanted to see that one thing, I can fast forward or rewind it to wherever I want to go. So that's a nice little feature. Okay? All right, I'm going to come back here to our lesson. So after we talked about that, I asked the kids to decide whether they thought the substances changed into a different substance, and they did. Coming back to our investigation question, can substances change into different substances? The answer is yes, absolutely they can. They have to be under the right conditions, and as we saw, like in this situation, they had to be dissolved in water at room temperature. But yeah, they turned into completely different substances. Why? Well, key concept number 5 says, this is a new key concept, during a chemical reaction, one or more starting substance or reactants change into one or more different substances or products. And so we're just reviewing our vocabulary. Reactant is a starting substance, and the product is the ending substance that's made during a chemical reaction. So lastly, this is a diagram that shows the reactants and the products for the chemical reaction that we observed in this lesson, both the macro scale when we actually did this lab in class, and then also what we saw in the sim. So again, we had our reactants were calcium chloride and sodium carbonate. We would say calcium chloride plus sodium carbonate yields, see the arrow in between the two boxes, yields NaCl, which is table salt, and CaCO3, which is chalk. Pretty interesting. All right. Let me know if you have any questions, okay? Talk to you later.